Okay, welcome back to Magic Tutorials for Chemistry. Let us discuss the reactivity of group number 16 elements with halogens. Correct? So, halogens, fluorine, chlorine, bromine, iodine, that is group number 17 elements. So, when they react, the group number 16 elements, when they react with halogens, they form the halides of three types, EX2, EX4 and EX6, where E is the element of group number 16. So, what it is forming? It will form a dihalide, it will form a tetrahalide and it will form a hexahalide. 6 are there, right? So, hexahalide compounds. So, 3 type of compounds it can form when it reacts with halogens. So, see the first point, we will discuss this. Monohalides like S2F2, S2Cl2, S2Br2, Sc2Cl2 are dimeric and undergo disproportionation. So, monohalide means what? Having one type of halogen. So, you can see in this compounds, element of group number 16, it is combining with one of the halogens. It is monohalide compound. Why? Because only fluorine, one halogen is used. Here also Cl2, only one halogen is present. Br2, bromine, one halogen. Same halogen, right? Even here chlorine, one halogen. So, it is monohalide like S2F2. What is the name of these compounds? Disulfur difluoride, disulfur dichloride, disulfur dibromide, diselenium dichloride, and they are dimeric in nature. Dimeric means what? Two molecules combining together or two units combining together. So, it becomes two units, that is dimeric. Correct. Di 2, mer units. So, dimeric, two units they will combine and it will form Sc2Cl2, S2Br2, and they undergo disproportionation also. Now, what is disproportionation? One element undergoing oxidation and reduction at the same time, that is called as disproportionation. One element undergoing oxidation and reduction simultaneously, that is called as disproportionation. So, check here the reaction Sc2Cl2, it gives SeCl4 plus Se. So, just balance the equation. I will write here 2, okay, and I will write here 3. Correct? 2 2s are 4 Se, 3 plus 1 4 Se, 2 2s are 4 Cl, 4 Cl. So, the equation is balanced. Now, find the oxidation state of selenium here. So, the selenium, the oxidation state is, how to find the oxidation state? So, 2 selenium are there. So, 2 into X, we do not know the value of selenium oxidation state, plus 2 into chlorine valency minus 1 equal to 0. So, 2X is equal to plus 2. So, X is equal to plus 1. So, what is the oxidation state of selenium in diselenium dichloride? It is plus 1. See the next oxidation state here for Se, X plus 4 into minus 1 equal to 0. So, X is equal to plus 4. Now, over here selenium, it is in the elemental form. It is not combined with any other element. So, the oxidation state of any element, if it is in the elemental form, it is present as an element, then it is 0. Correct? So, here it is plus 1, here it is plus 4, here it is 0. I will just take this. So, here it is plus 1, plus 4 and 0. So, now check plus 1 to plus 4. Increase in the oxidation state. So, that is oxidation. Plus 1 to 0. Decrease in the oxidation state. So, that is reduction. So, you can see selenium, it is undergoing reduction and oxidation simultaneously. Correct? So, that means they undergo disproportionation reaction. So this is the first point in case of halogens. We'll discuss about the dihalides, tetrahalides and hexahalides. Just make a note of this point. Next point here, all the elements except oxygen, they are forming dichlorides and dibromides and they possess sp3 hybridization. Correct. So all the elements, that is sulfur, selenium, tellurium, they will form dichlorides, dibromides of this form, right? SeCl2, SeBr2. But oxygen is not forming. Oxygen cannot combine with chlorine and bromine. What is the reason? So reason is oxygen, it is small in size, correct, and it is highly electronegative element. Compared to chlorine and bromine, if you check the size of oxygen, it is small. Chlorine, bromine, they are bigger in size and the electronegativity of oxygen is more than chlorine and bromine. So these two are the reason why oxygen is not forming dichlorides and dibromides. Now, the other elements, they will form dichlorides and dibromides and they will possess sp3 hybridization. So, I have just drawn here the Lewis structure for SeCl2. So, each atom, it should get how many electrons? 8 electrons. So, octet should be complete. So, here SeCl2 I have drawn here. So, each atom, if you count, it is getting 8 electrons. How? Check for chlorine first of all. It is forming a bond with selenium. That bond will have 2 electrons. 3, 4, 5, 6, 7, 8. Done, octet complete. Check for this chlorine. It is forming one bond with selenium. So 1, 2, 3, 4, 5, 6, 7, 8. Done. Check for the central atom, that is selenium. It is making 2 bonds. So 2 bonds means 4 electrons are there. 5, 6, 7, 8. So the octet is complete. This is the Lewis structure for SeCl2. Now, sp3 hybridization. Why it is forming sp3 and how it is forming? So the general electronic configuration of group 16 elements, that is Ns2Np4. 2 electrons in S and 1, 2, 3, 4. 4 electrons in p orbital. Correct. Now, Ns2Np4, sp3 hybridization is seen. So, how do you find the hybridization here, or how will you draw the structure? I have drawn the structure here already. How did you get that? So, if you see unpaired electrons, the unpaired electrons, it will form bond. Remember, unpaired electrons, it will form bond. So, how many unpaired electrons are there? 2. So, how many bond selenium is forming with chlorine? 1, 2. 2 bond. How many lone pair of electrons are there? LP, lone pair. So, 2 lone pair of electrons are there. So, how many lone pair electrons on the central atom? 2. So, 1 lobe, 2 lobe, 2 and 2. Correct. So, what geometry it is forming here? It will form tetrahedral. We know sp3 hybridization means it will be tetrahedral geometry. And why they are arranging in the way of tetrahedral? To minimize the repulsion. Correct. So, minimum repulsion will take place and the compound will be stable also. So, this is the way it arranges itself. It forms a tetrahedral geometry. Correct. So, check for hybridization, or how to draw the structure is, how many unpaired electrons are there? It will form the bond 1 and 2. How many lone pair? 2 LP electrons, 2 lone pair of electrons. So, 2 lone pair of electrons, I have put it in the lobe. It's called as a lobe. Correct. Just attach it, all the atoms, you get a tetrahedral geometry. So, the second point, hope it is clear to you. Just make a note of the second point. And oxygen, reason I told, it is not forming dichloride, dibromide. Why? Because of its small size and high electronegativity. Just make a note of this point. So, check the next point. So, we have discussed with EX2 type, that is dibromide, dichloride, correct. So, check with the next one, EX4, that is among tetrafluoride. Now we are discussing about EX4 types. So among the tetrafluorides, SF4, we are talking of fluorides here. SF4, it exists as a gas, SeF4 as liquid, and TeF4 as the solid. So what hybridization will be shown by them? Let us check that. We will take the example of SF4. So sulfur, electronic configuration, general electronic configuration I will write, that is for neon, Na2 NP4. So same way, Na2, correct, 2 electrons in s orbital and 1, 2, 3, 4 in p orbital, correct. Now SF4, so what it should do? 4 fluorine are there, so 4 it requires, right, 4 unpaired electrons it will require. So one of the electron from the p orbital, it will jump to d orbital. So 1, 2, s as it is, 1, 2, 3, one of the p orbital will jump to d orbital, because for sulfur it is 3s, 3p, 3d. 3d is existing, right? So it will jump to d orbital. Okay. So how many unpaired electrons are there now? 4 unpaired electrons and 1 lone pair of electrons. So 4 unpaired electrons means how many bonds it will form? 4 bonds it will form. And how many lone pair of electrons are there? 1 lone pair of electron is there. So the central atom, that is sulfur, it will get 1 lone pair of electron and it will form 4 bonds. Now see what will be the hybridization. Sp3, because 3 are there, and 1 in D, correct. S1 lone pair of electron, P3 1 1 1, 3 are there, and D 1 orbital we are taking. So Sp3D hybridization exists in SF4. Now if it is Sp3 hybridization, the geometry of the molecule is trigonal bipyramidal. And this geometry can also be referred as seesaw geometry. Seesaw geometry. Correct, in the garden and all kids will be playing on the seesaw. Correct, that type of geometry will be present. So remember, 4 bonds sulfur will form and 1 lone pair of electrons sulfur will have. Now 4 bonds with what it is forming? Fluorine it is forming, right? So how many fluorine are there in SF4? 4. So each of the fluorine, it will give 1 1 electron. Valency of fluorine is -1. So each fluorine will come electrons from fluorine, correct, 1 1. So it will be paired up. They will form the pair. So let's draw the structure, seesaw structure for SF4. Sp3D is the hybridization. Seesaw structure, it will be like this. I'm just drawing it. Okay, seesaw, I have just tilted it. If you check this part alone, it looks like a seesaw, correct? This is the stand and this is the plank on which 2 kids will be sitting. Just tilt this. This is the stand. This is the plank on which 2 kids will be sitting. Correct? So that is like a seesaw or trigonal bipyramidal also you can say. So sulfur, it is present here. F4. So 1 F here, F here, F here, 1 F. Correct? How many bonds it will form? 4, because it is having 4 lone pair, lone pair of 4, it is having unpaired electrons. So how many bonds? 4 bonds it will form. And 1 bond, it will be 1 lone pair of electron. So 1 lone pair of electron for sulfur. So the geometry is seesaw type. Correct. Now these 3 bonds, okay, these 3 bonds, the first bond, the second bond and this one, they are called as the equatorial bond. They lie at the equatorial position, so it is called as the equatorial bond, and the one top and below, that is called as the axial bond. So that is this one and this one, that is axial bond. The axial bonds will be always at 90 degrees, equatorial will be 120 degrees, and axial bonds, they are always longer than the equatorial bonds. Okay, and why they are arranged in this way? Just to minimize repulsion, because lone pair of electron is there, correct? So to minimize repulsion, they are arranged in this way. So hope it is clear to you. Among the tetrafluoride, we are just giving an example. SF4, it exists as gas, SeF4 liquid, TeF4 as solid, and one example we have given here. They will exhibit Sp3 hybridization. So how many bond it will make? 4, because 4 unpaired electrons are there. So 4 unpaired electrons means fluorine has electron, 1 electron. So each fluorine will give 1 electron. So 4 electrons from fluorine, it will combine or pair up with the unpaired electrons of the sulfur, and it will form the bond. And the s electrons, they will remain as a lone pair of electrons for the central atom. And these 3 bonds, they are called as the equatorial bond, and the straight line, that is this bond and this bond, it is called as the axial bond. Axial bonds, they are longer than equatorial bond, just to minimize the repulsion. Correct? Hope it is clear to you. We will move to the next one, but before that I will just draw the structure for SF4. Just make a note of this. With the bond angles I will be drawing. So just make a note of this. So check the structure for SF4 here. So it is like a seesaw only, correct? These 2 are the axial bonds. This is the equatorial bond with the lone pair of electron. I have written the bond angle here and the bond length also. So bond angle, the entire angle from this SF to SF, the entire bond angle, that is 187 degree. Okay. The bond length here, this one, this bond length, that is 154.5 picometer, and this bond length, it is 164.6 picometer. I told you these 2 are axial bonds, right? Axial bonds, and this is the equatorial bond. Axial bonds, they are longer than the equatorial bond. Axial bond, it is 164.6 picometer, and the equatorial bond, it is 154.5 picometer. Correct? Axial bonds are longer than the equatorial bond. So the overall bond angle here, that is 187 degree. The bond angle from this fluorine to this fluorine, that is 173.1 degree. 173.1 degree, and the bond angle between these 2 fluorine, that is the equatorial position fluorine, that is 101.6 degree. So this is the structure, the bond angle, the bond length for SF4. What I want to say is the axial bond length bonds, they are longer than the equatorial bonds. So just draw the structure for SF4. We will move to the next last one, that is EX6. So see the last one, hexafluorides, SF6, sulfur hexafluoride. So sulfur hexafluorides, the hexafluorides, they are the most stable and they exist in the gaseous form, And why they are stable? Because of the steric reasons, and their geometry will be octahedral. So I have drawn here SF6. So they exist in the gas form. They are stable because of the steric reason. Why they are stable? Because of steric reason. What do you mean by steric reason? It is protected by fluorine. Correct. Sulfur, it is protected by fluorine. Correct. It is protected by fluorine. So it is resistant to hydrolysis also. SF6. It does not undergo hydrolysis. It will be inert in nature. Steric hindrance is there, it is inert in nature, right? It is surrounded by 6 fluorine atoms. It is protected. So it will become inert. It will not react very easily. Correct? So it is inert in nature and resistant to hydrolysis. It does not undergo hydrolysis. So the reason why hexafluorides are more stable, that is because of the steric reason. 6 fluorine are there, or 6 halides are present, which will provide a protection, or we can say a steric. Correct? So these are the reasons why hexafluorides are more stable, and they possess a octahedral geometry also. Now stability of halides of group number 16. The last just one topic, that is stability of the halides of group number 16. So if they are combining with the fluorine, it will be more stable than chlorine, than bromine, than iodine. Correct? So stability of halides, it goes in this order. If it is combined, means the elements of group 16, if it is combined with the fluorine, it will be more stable. If it is combined with chlorine, it will be less stable. With the bromine, less stable. With iodine, very, very less stable. So what is the reason here? Down the group, what happens? The size increases. Down the group, the size is increases. Correct? And what happens to the electronegativity? Electronegativity is also decreasing. Correct? Now fluorine to iodine, if you move from fluorine to iodine, fluorine is the most electronegative, iodine less electronegative. So down the group, or when we move from fluorine to iodine, the electronegativity decreases and the size is increasing. Correct? Smaller the size, stability will be more, because fluorine and sulfur and fluorine, they both are combining, almost their size is same. But you compare with sulfur and iodine, sulfur will be small, iodine is big. So one small and one big means it will be unstable. Small, strong bond, stability. Correct? So stability of halides, it goes in this order. And why it is going in this order? Because as we move from fluorine to iodine, the size is increasing and electronegativity is decreasing. Okay. So here we finish with reactivity towards halogen. So just go through the videos, do the proper revision. So next video will come up with next topic. Thank you.